Okay, students, so let's get started with the past paper questions of density and volume. These are theory past papers applicable for O levels and IGCSE Physics 4th. An electronic balance is calibrated to display the weight of an object that is placed on its top plate. Okay, so basically, this electronic balance is displaying the weight. Okay. Figure, let me zoom out a bit. Figure 5.1 shows the balance with an empty measuring cylinder. Okay, the balance is initially with an empty measuring cylinder on the top plate. The weight is what? 1.203 Newton. Simple. A student pours a small quantity of oil into the measuring cylinder and records the volume and the new reading on the balance. Okay. Figure 5.2 shows how the reading on the balance varies with the volume of oil in the measuring cylinder. So basically, you are constantly pouring in oil in the cylinder, and your weight is also increasing, and your volume is also increasing. Okay. What do you have to do? The gravitational field strength is 10. You have to determine the density of oil. The gravitational field strength is 10. You have to determine the density of oil. So let's further move ahead. If you see this graph, this is the graph of weight versus volume. If I calculate the gradient of this graph, I will get weight over volume. And then if I can separate weight, like if I can break down weight, gradient is equals to mass into gravitational field strength divided by volume. If I can separate weight like this, that can you see this thing? This entire thing, mass over volume, will be equal to what? Density. That means if I can somehow calculate the gradient divided by density will give you the value of gravitational, will give you the, sorry, I have a mistake here. Gradient divided by the value of gravitational field strength will give you the value of density. Okay. So let's calculate the gradient here. First of all, let's take this point. This is x0, y 1.2. And then let's take this point. This is x90, y2. Can you calculate the gradient here? Yes, the gradient will be equal to what? y2 minus y1. 2 minus 1.2 divided by x2 minus x1. 90 minus 0 divided by 90. So zero point 0.8 divided by 90, this comes out to be 8.8 into 10 raised to the power of minus 3. You can also like do it till three significant figures. It will become 8.89 into 10 raised to the power of minus 3. Now you have the gradient. What can you do? You can divide this gradient by gravitational field strength. Let's do that. 8.89 into 10 raised to the power of minus 3 divided by 10, right? A gravitational field strength here was 10, I guess. It was given in the question. Yeah. The gravitational field strength is to be taken as 10. So let's divide it by 10. What does your value of density come out to be? Let's calculate that. Your value of density comes out to be 8.89 into 10 raised to the power of minus 4 kg per centimeter cube. So you can write this here. Your value of density, let me zoom out a bit, comes out to be 8.89 into 10 raised to the power of minus 4 kg per centimeter cube. Let's move on to the next question. Okay. A student records the mass and volume of two irregular objects, one made of iron and the other made of copper. Okay, so these are the mass and volumes of the objects made with copper and iron. The student uses the equipment shown in figure 1.1. Okay. Table 1.1 shows the results obtained. Okay. Describe how to determine the volume of an irregular object with the measuring cylinder. How will you determine the volume of an irregular object with a measuring cylinder? Have I taught you the three-step method? First of all, record the initial volume of the measuring cylinder cylinder without the object of the measuring cylinder without the object. Let's label this as VI. Second step. Second step, you will say that immerse the object inside the measuring cylinder. You will say immerse the object inside the measuring cylinder and measure the final volume VF. Immerse, immerse the object inside the measuring cylinder, inside the measuring cylinder and measure the final volume. And measure the final volume. Measure the final volume. The final volume. Okay. The final volume reading inside the measuring cylinder and measure the final volume reading from the measuring cylinder. Let's write it completely. Let's not give an examiner any chance to deduct our marks. What will be your last point? Your last point will be the difference in volume. The difference in volume gives us the volume of the object. The difference in volume gives us the volume of the object. Volume of the object. Simple as that. You have to calculate the density of iron. How will you calculate the density of iron? You are given the mass. You are given the volume. Density is equals to mass over volume. I don't know why there are 2 marks for this. This is literally a grade 1 question. 400 divided by volume. 400 divided by 51. This gives you an answer of 7.84 grams per centimeter cube. Okay. A third object which is also made of copper. That means it will have the same density as copper, has the same volume as the iron object. Okay, its volume is the same as the iron object. Calculate the mass of this copper object. We have to calculate the mass. Okay, mass is to be calculated. Can I calculate the density of copper first of all? Let's calculate the density of copper. The density of copper will be equal to what? Mass over volume. What is the mass of copper? 350 divided by volume, that is 39. So 350 divided by 39. Your density of copper comes out to be what? 8.97. 8.97 grams per centimeter cube. What is the volume of iron? The volume of iron is 51. Let's multiply both of them. Since you have to calculate mass, mass is density into volume. What is density? 8.97 multiplied by volume, that is 51. Yeah, let's multiply it with 51. Your mass comes out to be what? Mass comes out to be 457. 457.6, that can be converted to 458 grams. According to 3 significant figures, the mass is 458 grams. State and explain what happens to the density of the iron object when it is heated. So, as the iron object is heated, the volume increases, density decreases. Simple as that. Simple as that. Let's further move ahead. Equal volumes of metal, water, and air are heated from 20 degrees centigrade to 80 degrees centigrade. State whether the metal, the water, or the air expands the most. Which will expand the most? Obviously, air, since air is the gas. Gases expand the most. Figure 3.1 is a diagram of metal at 20 degrees centigrade. The metal is a large square sheet with a square hole at its center. The sheet lies flat on a table. Okay. On figure 3.1, draw the outline of the sheet and of the hole. After the metal is heated, make sure that the expansion is noticeable. So if you increase the temperature, what will happen? Obviously, this square will expand. Oh, I should draw it with a scale. Obviously, this square will expand like this, and the whole will also expand like this. Simple. These purple lines is how your square will look like now. The metal has a mass of this, a density of this, define density. Very, very easy. Mass per unit volume. Okay. Calculate the volume of the metal. We have to calculate the volume of the metal. Okay. So density is equals to mass over volume. Volume will be equal to what? Mass over density. Mass is what? 5. Density is what? 7.5 into 10 raised to the power of 3. Can you calculate the volume? Yes. 5 divided by 7.5 into 10 raised to the power of 3. This comes out to be 6.66. 6.6. Yeah, 6.67 into 10 raised to the power of minus 4 meter cube is your answer. Simple as that. Also, let me tell you an important trick. Can you see these past paper codes? You can go to these codes 5054 May June 2018 question 3 and can see the marking scheme from there. So yeah, this will also verify your answers. Figure 3.1 shows a thin sheet of plastic. A student tries to measure the thickness of the sheet with a ruler. Very absurd thing done by the student. But the sheet is too thin to measure accurately, obviously. The student measures the mass of the sheet and the value comes out to be 0.12 grams. Okay. State what is meant by mass. Amount of matter in a substance. Amount of matter in an object. You can say that in an object. Okay. Now let's say the student is told that the density of plastic is this. You have to calculate the volume. Very easy. Volume is equals to mass over density. What is your mass? 0.12. What is your density? 0.91. What will your volume come out to be? 0.12 divided by 0.91. This comes out to be 0.132. This comes out to be 0.132 centimeter cube. Okay. The student measures the length and width of the sheet. The readings are obtained. Calculate the thickness of the sheet. Okay, we know that the volume of the sheet is what? Length into width into thickness. You already have the volume 0.132. Your length is 3 centimeter. Your width is 2 centimeter. What will your thickness be? 0.132 divided by 6 is equals to thickness. This comes out to be what? Answer. This comes out to be 0.022 centimeter. This is your thickness of the sheet. Okay, this is your thickness of the sheet. Yeah, I have written it correctly. State a measuring instrument that can be used to measure the thickness of the sheet accurately. Obviously, a micrometer screw gauge. Such low values of thickness can only be measured using a micrometer screw gauge. Okay, so yeah, that's it for density and volume past papers. If you have any question, you can ask in the comments.